Hello and welcome to our AI paper review. In this video, we'll talk about Stanford Alpaca, an instruction-following language model that's been making waves in the academic community. But what exactly is Stanford Alpaca, and why is it important? To answer that question, let's start with why the Stanford Alpaca exists. As we know, language models like GPT-3 and ChatGPT have become incredibly powerful, but they still have some major deficiencies. They can generate false information, propagate social stereotypes, and produce toxic language. And because these models are closed source, it's hard for researchers to study and address these problems. That's where Stanford Alpaca comes in. It's an instruction-following language model that's been fine-tuned from Meta's LLaMa 7 billion parameters model, and it's been specifically designed to be easy and cheap to reproduce. The goal is to give researchers an accessible model that's capable of performing at a level similar to the closed-source models, so they can study and improve upon these models. So what can Stanford Alpaca do? Well, it's an instruction-following model, which means it's designed to follow specific commands or instructions. And according to the creators, it performs quite well on a diverse set of inputs. In fact, in a blind pairwise comparison between Stanford Alpaca and OpenAI's TextDaVinci 003, the two models had very similar performance. Stanford Alpaca even won slightly more comparisons than TextDaVinci 003. But it's important to note that the Stanford Alpaca does have limitations. For one, it's not designed for commercial use, only for academic research. As such, the demo only allows for one round of conversation, where the user provides an instruction and Alpaca provides a response. Finally, the creators have not yet designed adequate safety measures, so it's not ready to be deployed for general use. So how did the creators of Stanford Alpaca train the model? There were two important challenges they had to overcome: finding a strong pre-trained language model, and obtaining high-quality instruction-following data. To address the first challenge, they used Meta's new LLaMa models, which are some of the strongest pre-trained language models available. For the second challenge, they used an existing strong language model to automatically generate instruction data. Specifically, they used TextDaVinci 003 to generate 52K instruction-following demonstrations. Equipped with this data, the creators fine-tuned the LLaMa models using Hugging Face's training framework, which takes advantage of techniques like fully sharded data parallel and mixed precision training. The initial run took 3 hours on 880GB A100S, which costs less than $100 on most cloud compute providers. They note that training efficiency can be improved to further reduce the cost. So there you have it, a brief overview of Stanford Alpaca. And as always, feel free to leave your thoughts and questions in the comments below. Thanks for watching.